Hi and welcome back to Down the Shed. So on this episode we're going to do experiment number 4, parallel pipes. So by following the workbook we're going to connect the wires according to the wiring checklist. Take a look at the schematic. There is a low a 3.3 k ohm resistor and a high 100 k ohm resistor in parallel, connected between the same points in the circuit. How bright do you think the LED will be? Press the switch and see if you're right. So let's do that. So we're going to wire 2756, so that'll be power plus to the switch. I'm using some of these DuPont, I think they are, style connectors out of a Arduino kit. We want 55 to 52 and then 52 to 43. And I am doing this upside down, so that's switch to the 100 k ohm and then the 100 k ohm to the 10k, no, the 3.3 k ohm. Like so. 51 to 42. So that's the 100 k ohm to the 3.3 again, so we're in parallel. And then 42 to 3, which will be the LED. If you remember, I did actually change these out, so we want a longer wire for that. That'll do nicely. What are we doing? 51, 42, 42 to 3. This is a very cardboardy kit, this electronic playground. Not like the old Tandy or realistic kits that I had when I was a kid, which were much more sturdy and wooden boxes. I will get a hold of one on eBay at some point. So we want to do 4 to 26, which will be the other side of the LED back to the power. That might do it. Let's put a longer one in. I'll do. So LED to minus. That's LED minus to minus of the power. Let's plug the battery in. Remember, I also changed the battery pack on this. So let's kill some lights. That in there like so. So we now have our circuit wired up. So press the switch and see if you're right. The LED is bright. The LED is bright, so most of the current must be flowing through the smaller 3.3k resistor. This makes perfect sense when we look at the water diagram, with most of the water flowing through the pipe with less rocks. In general, the more water pipes or resistors there are in parallel, the lower the total resistance is, and the more water or current will flow. The relationship is more complicated than for resistors in series, and is given here for advanced students. For two 10k resistors in parallel, the result would be 5k. The 3.3k and 100k in parallel in our circuit now give the same LED brightness as a single 3.2k ohm resistor. To demonstrate this, disconnect the wires from the 100k resistor and connect them to the 10k. Press the switch and the LED should be just as bright. The total resistance is now only 2.5k ohm, but your eyes probably won't notice much difference in LED brightness. So let's do that. So we'll take that out of the 100k and put it into the 10k. That comes out of the 100k and goes into the 10k, as does this. And there we go. Appears to be no difference. The total resistance is now only 2.5K, but your eyes probably won't notice much difference in LED brightness. Now disconnect the wires from the 10K and connect them to the 1K. Press the switch. The total resistance is now only 770 ohms, so the LED should now be much brighter. So we'll disconnect the 10K and connect to the 1K. I don't know if the camera will notice if there's much difference there, but that's definitely brighter from where I am. So that is circuit 4 of parallel pipes. And what we do for a bit of fun is we'll disconnect the 1K and we'll go with the 470 ohm and see if we get any difference in that. So that's experiment 4, parallel pipes. We're now going to do a comparison of parallel currents. So that will be experiment 4B in the next video. So like the video, subscribe to the channel if you want to see more of the Elenco electronic 51 playground projects. Thanks for watching. I hope you enjoyed this short video and I'll see you in the next one.